So in my previous video, I had shown you how to make a Arduino IoT cloud based temperature and humidity sensor using ESP32 and dht22. But in this video, I had only shown you the hardware configuration, wiring, circuit diagram and these hardware parts. But I had not explained the Arduino IoT cloud setup and the programming part. In this video, I will cover the full Arduino IoT cloud setup from scratch and the programming part also. So stay tuned in the video. At first, we have to configure the Arduino IoT cloud. For that, search on any browser Arduino IoT cloud and go to the first link. Here you have to press get started for free, and here you have to create an account if you had no any account, but I have one, so I will log in into this. So this is our total Arduino IoT cloud interface. Here there is our account, and at first option is home, then sketches, devices, things, dashboard. I will tell you how to use them and what are the exact works of them. So at first we have to go to device and you have to set a new device here from the top corner. Here you have to select which board you are using, any Arduino board or any third-party device. So I am using ESP32 for my project, so I have to select third-party device, and then there are three options: ESP8266, ESP32 or LoRaWAN. We have to select ESP32. If you are using ESP8266, you have to search for ESP8266 and then here search your exact ESP32 board model. Mine ESP variant is ESP32 dev module, so search for it, ESP32 dev module, and here it is on the second number, and press continue. Now you have to give a name of your device and they will suggest something, or you can change this. Here is Eva and it's good, so press next, and here are some important informations. Here is device ID, then a secret key. And here the secret key is very important because without the secret key your code will not work and you cannot get the secret key later. So you have to download a PDF here. Just press download PDF and it will download a PDF with the device ID and secret key as a PDF format, and then press I save my device ID and safety key and continue it. So it's done. It means our device setup is already done. Now we have to complete the next step. For that, press here and go to things. So in this project we are using a dht22 sensor with ESP32. So from dht sensor we are getting three kind of data. One is humidity, one is temperature, and another is a heat index. So we have to set three variables for these three data to display them on Arduino IoT cloud. So go to things and here again create a new thing on top right corner. At first you have to add variables. To add a new variable, press add and you have to give a name to your variable. At first I will set a variable for my temperature of dht22 data. So let's name it temperature underscore C because the temperature data will come in degree centigrade, and then variable type, here search for temperature. You have to select the other option also, and here is temperature sensor degree centigrade, temperature sensor degree Fahrenheit. So we are selecting temperature degree centigrade, and here is an important thing, variable permission, read and write. You have to select read and write if it is a button or this kind of thing which communicates both way, from Arduino IoT cloud to ESP32 or from ESP32 to Arduino IoT cloud, that are read and write. But sensor only send data one way from ESP32 to Arduino IoT cloud, so sensor will be always read only. And variable update policy is on change. It means when the data will change, only this time the ESP32 will send the updated data to the Arduino IoT cloud. So that's it, you don't have to change anything on threshold, just add variable. So here our first variable is setted, temperature underscore C. Add another variable for humidity, we will give it a name humidity, just humidity. Select variable type, again search for humidity, select all other options, maybe there will something. Yes, here is a relative humidity, select it, and it will automatically declare a variable for it which is cloud relative humidity, and again it is a sensor, so it will read only, and variable type is on change. Add variable, our two variables are already setted, and one last variable we have to set which is heat index, so name it heat underscore index, and search variable type. Heat index is basically also a temperature, so search for temperature and it will come in degree centigrade, so I'm again selecting temperature sensor degree centigrade, and this heat index declaration is cloud temperature sensor, and again for sensor it will be read only and on change. Add variable. So we had successfully added our three variables. First is heat index, second is humidity, and third is temperature. Now we had to set up these things. Associated device, we have to connect a device for this. Our last setted device was EVA. EVA is not connected with any variable or anything, that's why it is open, and you can say this device is connected with test Soikot project. So we have to select the proper device and it will automatically attach with it. As you can see, EVA is connected with it. And now network configuration, we have to give our Wi-Fi SSID and password here, and also the secret key. So I am filling it, my Wi-Fi SSID password, and the password is 2002, and we have to give the secret key here. For secret key I am going to the PDF, and here I am copying the key, secret key, just paste it here and press save. So our network is setted. Here are also other options. Smart home integration, it means you can connect your project with Amazon Alexa or Google Home, but I will try these things on a later video. So for now our thing setup is completed. Now we have to set up the dashboard. For dashboard setup, click on dashboard, and again to create a new dashboard you have to press here on top right corner. Here you can rename your dashboard. I am naming it tutorial, rename. And to set up your dashboard you have to press here edit, and at first we have to add a gauge. This gauge will indicate our temperature value, so we have to rename it from gauge to temp underscore C. And the next option is link variable. Here we have to connect our variable with the particular gauge, so press the link variable and select which variable you want to show in the gauge. I want to show the temperature in the gauge, so press the temperature C and press link variable. So the temperature underscore C is already connected with this temp underscore C gauge, and here is show thing name on widget, just turn it on. Then next is value range. You can set the maximum and minimum value which will show in the gauge. So 0 degree centigrade temperature is uncommon for here, so here I am setting it 10 degree centigrade, and 100 degree centigrade for a weather is uncommon, so I am setting it into 80 and press done. So our first gauge is selected. You can increase or decrease the size by pressing here, and this is our first device. Now add a second gauge. This will show our heat index, so name it heat underscore index. This is heat index. Now again we have to link this gauge with a variable, and we will connect it with the heat index variable and press link variable, so thing name, and heat index we will also make it from 10 degree centigrade to 80 degree centigrade. This is more than enough range. When it will 80 degree centigrade on weather, we human will not exist or not YouTube will exist. So press done, and again we have to add our third variable which is percentage for showing the humidity percentage on the air. Rename it humidity, and again link variable, only humidity is in percentage, so you can only display the humidity using the percentage here. And you can here set a custom icon. If you are displaying any kind of battery voltage related thing, you can press on battery. Here is Arduino logo, time logo, robotics, bulb, various kinds of symbols here available. I am monitoring the humidity, so I am searching, and I think for humidity purposes this water drop is the best option, so I am selecting it. Then press the threshold. If you want to change the color of the gauge under or over a particular value, you can set it here. It is by default set it at above. You can also set it below, so I'm keeping it above. And if the humidity level is above 45%, it will turn red, or you can select any other options also from here, so keep it red for right now and press done. So our 3 gauges are already setted here. Now for proper visualization, we can also add 3 charts here, which will kind of graph, and you can also add these graphs with the same variable, so that you can easily visualize in how much time it has increased or decreased how much. So the first graph, we are setting it for temperature, showing temperature value, so name it temp underscore c again, and link variable, I'm linking it with temperature because I want to show the temperature in the graph. So it has attached, turn it on, and here are 2 options, line and spline. So the spline is the good, I think. So just press done. Again the similar way, and then another graph, I will show the heat index in this, so name it heat underscore heat index, link variable, link it with heat index, and done. Add another chart for the humidity, rename it humidity, and here is the difference between line and spline, as you can see, but it is a visual difference only, and link it with humidity variable and press done. So our Arduino IoT Cloud's PC dashboard is already ready, but you can also set up it for your mobile. For setup for mobile, you have to press here the mobile icon, and here you can see how it will show in the mobile app. So I am readjusting this windows here, and you can also increase or decrease their size here also. I am rearranging them all, make them all middle, and I have to increase its size a bit, and I think our mobile interface is also good to go. So once you had finalized your all setup, just press done, and your dashboard is also ready. Now only thing you have to do on Arduino IoT Cloud is you have to download the code here. Yes, the Arduino IoT Cloud also provide you the main basic code, and you have to add just logic on this code. So get the code, press on things, and then press the thing which code you want to get, and you can remember it. Here we had set our variables in the top corner. Here is the sketch option, press on sketch, and also you can write your code here and directly upload from here from web browser, but I don't do this. I just download the code from here. Just press it, and it will download your code and other files as a zip file, and already we had the code here. So in this way you can set up your Arduino IoT Cloud. It is very easy. Now let's see the programming part. Now let me show you the programming part. We had already downloaded the Arduino sketch from the Arduino IoT Cloud, and this is the file. So I'm copying this zip file into another folder and extract it. Open the file and you will get a Arduino IDE sketch here. Open the sketch and this is our main Arduino code. We just have to add the sensor and logic in this code. There are several parts of the code. Navigate to the last part and here you have to set the SSID password and the secret key. SSID password means your home Wi-Fi's name and password. So at first set them. You have to set this SSID and password according to your hotspot. Now open the previous PDF file and copy the secret code and paste it here. Now our main programming part. For reference, I am using the dht22 Adafruit library here. DHT sensor library, DHT test. So this is a pre-written example of dht22 sensor. I am going to use this as a reference for my main code. At first, take the library which is #include dht.h and paste it behind the library section. Then we have to define the DHT pin and then define DHT type. It means there are two type of DHT sensor on market, DHT11 and DHT22. If you are using DHT11, then use this line above, and if you are using dht22, then this line is okay. Let me increase the font a bit so that you can easily watch this. And this line also. Now check your schematic and notice in which pin you had connected the DHT sensor's digital output to the ESP32. I had connected it on digital 4, so I am changing it into 4. Now you have to copy these lines from white setup and paste it here. And now the main coding part. For the main coding part, you have to copy the whole void loop section of the example code. And paste it here. Now we don't need the example code anymore. Make it full screen and let's understand the code. Here you can see 3 lines. Float h equals to dht.read humidity. Using this line, our ESP32 can read the humidity data from the DHT sensor. Next is float t dht.read temperature. It means using this line, our ESP32 can read the temperature data from the sensor, and this data will store in the variable which is t, and the humidity will store in the variable which is h, and there is also temperature in degree Fahrenheit, and that is stored in F. And here are 2 more lines. Float HIF equals to DHT compute heat index. It means the ESP32 will calculate the heat index and store the data in HIF. This will be in Fahrenheit. And HIC, it means it will compute the heat index data in degree centigrade and it will store into the HIC. So we have to remember these float values, inside which float value which data is there, and we will use this in our programming. Scroll to the top of the code. In Arduino IoT Cloud, we had defined some variables. These 3 are the variables, which is heat index, temperature underscore C, and humidity. So we have to copy this. Just copy these lines and go the bottom of the code and paste it. Now you just have to keep the variable part and remove the front part of it. Now the heat index will send the heat index data to the Arduino IoT Cloud, and our heat index in temperature is stored into HIC. So copy the HIC and paste it here. It means heat index equals to HIC. The HIC heat index data it will send into the Arduino IoT cloud. In the similar way, we have to paste here the temperature in degree centigrade. Here temperature in degree centigrade is T. So just take the T and paste it here. In the similar way, the humidity is stored into a float which is small h. So using this only 3 lines, we can update the dht22 sensor data into Arduino IoT cloud. Now we have to compile the code and upload it into ESP32. This is my ESP32 on a 0 PCB board connected with the dht22 sensor. There are also other sensors, but they are not currently using in this project. I'm just connecting the dht22 with the ESP32, connect it with a micro USB cable and connect it with the laptop. Now select board and change the board type here. Search here ESP32 dev module, this one, and press OK. Now just upload the code. Here is my Arduino IoT cloud open, and till there is no any data because our code is not fully uploaded till now. Once it will uploaded and it will connect with the Wi-Fi, then it will send the dht22 sensor data into the Arduino IoT cloud, and we can see the data on the dashboard here. Now our code is successfully compiled and it's uploading now. The code is uploaded. Now open the serial monitor. dht22 sensor test. We are getting the humidity, temperature and heat index data. Connecting with Wi-Fi. It's already connected with Wi-Fi. And now let's see the dashboard of Arduino IoT cloud. And within a few seconds our data is already live on Arduino IoT cloud, and you can see the data is changing here with the graph. So this was a complete tutorial video on how to set up Arduino IoT cloud from scratch, how to write code for ESP32 and dht22 sensor based temperature and humidity monitor. Actually, I had made a Arduino IoT cloud based temperature and humidity monitor for one of my school life photographer friend. He want to monitor his camera boxes humidity and temperature because the camera is very sensitive to humidity. So this was the full programming and setup part of the video. If you want to watch the previous video for hardware setup, circuit diagram and everything is there, you can watch the video. I will put the link of the video in the description box. Hope you had learned something new from this video. My English is not so good, sorry for that, but I think you can easily understand what I am trying to say in this video. So stay tuned in my channel. I will make a lots of video on Arduino IoT cloud, how to use each and every function, each and every variable and widgets which are there. So do subscribe my channel. A lots of Arduino IoT cloud based interesting videos are coming on my channel. You can use those projects in your school project or college project whenever you want. So stay with me. Hi, I am Akash Bag, call sign Victory Uniform number 3 Hotel Alpha X-ray. I'm an electronics and communication engineering student and a licensed ham radio operator also. I used to make videos on microcontrollers, microprocessors, various kinds of sensor, ham radio, antenna, IoT, 3D printing, RC plane drone, this related topic. So if you are interested in this topic, consider to subscribe my channel. And if you have any questions, queries regarding this video, let me know in the comment section, or you can reach me on my Instagram ID. Instagram ID is also in my description box. So that's it for today. See you on another video. Bye.